Welcome, good evening everybody to this first Google Hangout, a series of 2 Hangouts just before the Mercury transit happening in a little bit more than 3 weeks from now. An event which is not something you see every day. And to properly prepare for this event, I have 3 very special guests with me who will be joining us tonight for this 30-minute hangout. And for the audience, you will also have the chance of asking questions. Actually, on your right side of the screen, there should be a Q&A session tab available. So if you have any questions, just put them forward. I will screen them and put forward the most interesting ones to our experts. Speaking of which, I'm giving a warm welcome to the 3 of them, and I would like to ask them to briefly introduce them. Let's first switch to the United Kingdom, to the Open University. Professor Dr. David Rothery, you're with us tonight. David, would you care giving a little bit about some insight about yourself?
Yes, well, hello everybody. I'm David Rothery. I'm involved in the Bekaa Colombo science team. That's the European Space Agency's mission to Mercury. The instrument I'm most closely involved with is MIX, the Mercury Imaging X-ray Spectrometer, with which we're going to map Mercury's surface composition in X-rays in unprecedented detail. But I'm excited about the whole of Mercury, not just its chemistry. Geologically, it's a fascinating body. I'm a geologist, and I really like what I've seen on Mercury so far from NASA's Messenger mission, and we'll get a much better view when we get Bekaa Colombo there.
Awesome. So this must be a fairly exciting time these years, for you, I guess.
It's been great. We had 4 years in orbit with Messenger. Wonderful, wonderful data. And it's really making me hungry for more, because Messenger's orbit was such that it could do a good job in the northern hemisphere of Mercury, but it had a very elliptical orbit because it wasn't able to stay close to the planet for a long time, because it would have the sun on one side and a hot planet on the other. It had to get away from the planet. So they sorted that out by having an elliptical orbit. So the southern hemisphere was not well studied. We will do both hemispheres equally well with a bigger suite of instruments. So it's going to be exciting times.
Speaking of which, as we are talking about things to come, even more exciting times, there's another mission at hand, which is embarking for the first planet in the solar system. And who better to talk about this project than our next guest, Gabriele Cremonese from Italy. Gabriele, would you care to talk a little bit about your background?
Hello. Yes, I'm an astronomer. I'm working in Padova, the Astronomical Observatory of Padova in Italy, and I'm strongly involved in the Bekaa Colombo mission, as I'm the principal investigator of Symbiosis, that is the main instrument to remote sensing the surface of the planet.
Very well. So I understand you're right now based in Padua?
Yes.
Okay, very well. So joining us from the south. Let's go to the east, the far east, at least from the location where I am. I'm based in Innsbruck in Austria. My name is Gernot Groemer. I'm with the Austrian Space Forum. And my team is basically building spacesuits, not for Mercury, but for a different planet, Mars. But let's return to our hangout here. Oana, Sandu, you are with the European Southern Observatory.
That's correct. ESO is a European organization with 15 member states, and it builds and operates some of the most advanced ground-based telescopes in the world. All of them are based in Chile, but our headquarters are in Munich, Germany. I work with the outreach department. I'm an astronomy communicator, not a scientist. And I'm here tonight because we're organizing ESO's first social media gathering, which happens to take place during the Mercury of transit. So we'll be talking a bit about that as well.
You will not be alone during this very exciting journey, I understand. Remco Timmermans from the Netherlands is joining as well, again from an educational institution. Remco.
Yes, hello. My name is Remco Tournaments. I'm a faculty member of the International Space University, where we will organize the Space Studies program summer school this year in Israel. I wear 2 hats in this discussion: my university hat, but also my social media hat. As some of the viewers will know, I'm pretty active on social media. where I talk about space most of the time, and I'm one of the very lucky people that is joining Oana in just under a month from now on this trip to Chile to report live on a lot of stuff, including the transit of Mercury that we're talking about today.
Very well, thank you for this introduction. Well, David, we've been talking a little bit in the preparation for this hangout that Mercury transits are something which is having a little bit of history in terms of that obviously it's not the first one to observe, and it seems that there's quite some background stories in the previous centuries, actually, I must say, on the history of Mercury transit and the observations, basically laying or being one of the first conceptual proofs of our modern view of the solar system, which changed from being geocentric to heliocentric at the many hundred years ago. David, could you tell us a little bit about the history of the observations and the history of the expeditions?
Well, yes, sure. Mercury transiting the Sun is too small to see in front of the Sun with the naked eye. You shouldn't stare at the Sun anyway, but if you did, you wouldn't see Mercury, it's too tiny. But you can actually see Venus crossing the Sun if you can protect your eyes by having a big cloud in the way. But nobody had ever seen Venus crossing the Sun before the telescope was invented, which is a surprise. If people had seen a transit of Venus across the Sun with the naked eye, they would have realized that the planets must go around the Sun, not around the Earth. But nobody did notice this. It wasn't until 1631 that an astronomer in Paris, Pierre Gassendi, observed a transit of Mercury, and that was the first planetary transit ever observed. And that was clear proof that Mercury had to be passing between the Earth and the Sun. It was Johannes Kepler, the guy that discovered the elliptical shape of orbits, that predicted this. He had predicted a transit of Venus in the same year, but nobody managed to see that from Europe because it happened at night, so it wasn't visible here. The first transit of Venus wasn't seen until 1639. So it was proof that Venus and Mercury were traveling between the Earth and the Sun. Actually, we knew that already because with telescopes you can see the crescent shapes. So from the illumination geometry, you can work out that those planets go between the Earth and the Sun. Next important thing historically was Edmund Halley, the chap that predicted Halley's comet return, for example. He was sent to the island of St. Helena in the South Atlantic to try to map the southern sky. It wasn't very successful because it's pretty cloudy on St. Helena, but he did observe a transit of Mercury in November 1677, and he realized, and if somebody else was watching this, say from Europe, and we could time how long it takes Mercury to cross the Sun from these two vantage points, we can use this to work out the distance from Earth to Mercury and from Mercury to the Sun, and therefore the Earth-Sun distance, and get the scale of the solar system, get the astronomical unit, which had never been determined very accurately at that time. So Halley realized that transits were going to be important for measuring the scale of the solar system. And transits of Venus are better than transits of Mercury for this purpose, because Venus is a bit closer to the Earth, it's a bigger object, easier to observe. And that's why Captain Cook, the very famous explorer Captain Cook, was sent to Tahiti in 1769, where he observed a transit of Venus across the Sun. In fact, later the same year, from a place now called Mercury Bay in New Zealand, he saw a transit of Mercury as well. But that expedition, which was very important, certainly in my country, in Great Britain, for opening up the Southern Ocean, was financed by the need to get an observation of the transit of Venus from the southern hemisphere so we could measure the astronomical unit. So there's some distant history.
So it seems that the transits always have been some sort of a measuring stick for astronomers. And I also understand that during the first observations actually of Mercury, it was pretty scary to see how tiny the planet Mercury was against this huge backdrop of the giant sun we all enjoy so much. However, until the modern age of more deep space, more detailed observation, of course, the time of spacecraft flying by the Mercury, the planet itself was not much more than a little dot in the night sky with a lot of features. However, we understand it's a very colorful, it's a very diverse world, which has a lot of stories to tell, actually. So how about, David and Gabriele, if we talk a little bit about our modern view of Mercury, and basically, if you've just read maybe the Wikipedia article about Mercury, so what is the most important things one should know about Mercury? David, if I may ask you to start with first.
Okay, well, it's a very dense planet. It's a rocky planet like the Earth, but for its size, it's very dense, and we know from that it must have a very big iron core relative to the size of its rocky exterior. Now, I'm going to try and be smart here and show you a picture of that. Let's see if this is going to work. I'm not screen sharing, am I?
Yes, we are seeing an image, so with some luck.
Okay. Yep. I want to show you this picture here, if you're patient. Sorry for the delay. Okay, this is a model of Mercury's interior. You see it has a very big core. Yeah. The outer part we know is fluid because it's generating a magnetic field.
Sorry,
that was not expected.
We're not seeing it yet.
I
try again with the share. I think we are still back on your video. And I'm sure you have some great pictures.
Yeah, I'm sorry. Now you should see it.
Okay, let's give it a few seconds. Here we go.
Okay.
Yeah.
So this is its core made of iron. The outer part is fluid, it's convecting, and that's where the magnetic field is being generated. That was a big surprise. That was a discovery when the first space probe flew past Mercury. That was Mariner 10 back in the 1970s. And the outer part is the rocky bit. This is the crust, the outer part, and this is the warmer rock in the interior, the mantle. That's solid, but it may be convecting. And this rocky part is very thin compared to the size of the core. And we infer from that that the planet was involved in a giant collision of some sort, which stripped a lot of its original rocky material away and left it impoverished in rock. But surprisingly, it didn't strip away Mercury's volatiles, because Mercury is rich in all kinds of elements which turn to vapor very easily, like sulfur, like chlorine. It's rich in potassium, and it's rich in some other things that are volatile, but we don't know what they are. I'll just whiz through these slides and show you the surface. This is a view of the cratered surface of Mercury. So there's a crater here, but there's this linear feature crossing it. It's shadowed. It's a scarp slope. Mercury's crust has been pushed from left to right to form that contractional fault. So Mercury's been shrinking. And then what else? Large areas of it are covered in volcanic lava flows. Gernot, you said Mercury is colourful, but well, here's a colour image. It's not very colourful unless you work hard to exaggerate the colour.
Absolutely, yes.
Which I'm doing now. This view is about 1,000 kilometres across. Up here in the upper right, it's some red, smooth lava flows.
I think you have to move on with the pictures. We're still with the...
You're not seeing new pictures?
No, we're seeing still the image with the layers of the interior.
Oh, okay, it's not shared.
Now we go. Now we see it. Now we see it.
There's the fault. Yeah.
Absolutely, yeah.
Here's the colourful view. And not much colour, and then I exaggerate the colour.
Very well. So
it's a fascinating world for a geologist. I should let Gabriele speak, shouldn't I?
Absolutely. I was just saying that the surface is something which is of high interest to Gabriele. Can you give us a reason why it's the most important thing for studying the geology, Gabriele?
But we have to understand that Mercury is called as an end member of the solar system. It means because it is just at the one end of the solar system, the closest bodies to the Sun. It's clear that this is important in order to understand which was the origin of the solar system and the evolution. Studying the closest bodies to the Sun, we may have an idea how was the pre-solar nebula, just at the origin of all the planets in the solar system. And so, studying the topic, we may have an idea why we can see so many craters, which is the distribution of impact craters on the surface, for instance. It has a meaning in terms of flux of impactors, just in the inner side of the solar system. we have to take into account that the solar system is divided by two main regions. We have the inner solar system characterized by 4 terrestrial planets that we call terrestrial planets because they are very similar. They have similar density, composition, and size. And then we have the outer solar system, where we have the giant planets composed mainly by hydrogen. They are huge, they are much larger planets, and the density is much lower than Mercury and the Earth. So it's clear that in order to understand better the evolution of the planet, we have to understand the end members, as is Neptune, the outest planet of the solar system. Mercury is the closest. This is the reason why we are so interested to study Mercury.
Gabriele, we just have a question coming in from the audience, from Deliliant. And he's asking, can a transit better show the solar wind going around the planet? I don't think that we're going to see a lot of solar wind interaction during a transit because it's hard to observe. However, I think Bekaa Colombo is also not just looking on the surface, but also the environment of Mercury. Is that true?
Yes, it's true, because Bekaa Colombo has 2 modules. There are one module, the Mercury Planetary Orbiter, that is devoted to study the internal structure of the planet, the surface and composition, and then the fundamental physics questions. And then we have the magnetospheres module that is realized in Japan, and this module will work on the magnetosphere and the exosphere of Mercury and the interplanetary medium. In the interplanetary medium means the solar radiation and the solar wind, all the ions and electrons coming from the sun.
Absolutely. Well, there's another question, and probably that's something we can address to Remco maybe, and that is, do you need a telescope to watch the transit, or can you see it with the naked eye, including solar glasses, of course?
Yeah, actually, David referred to that all the way in the beginning. It's never a good idea to look into the sun, especially since, as David said, you will not be able to observe the Mercury transit with the naked eye. Also, not with these special solar eclipse glasses. Of course, you can observe it with a telescope, but that's even more dangerous. Never use binoculars or telescopes to look straight into the sun. That's super dangerous unless you have a professional solar scope that is operated by a professional person. You will be able to see it. Actually, that's one of the reasons why we're going to Chile, because they have, well, I guess the most professional equipment anywhere in the world, where we will be able, under the guidance of professionals, to see the Mercury transit very well. But don't try with the naked eye. Never try with anything like binoculars or telescopes unless you know absolutely what you're doing.
Well, lots of societies, lots of astronomy clubs are organising events. They know what they're doing, and they will have telescopes out all over Europe. ESA has a website where you can find events. It's also going to be web streamed from various solar telescopes and from satellites in space. So even if it's cloudy, people can go on the internet and watch the transit.
Very well. Oana, there's Remco already mentioned that you will be having a very exciting trip ahead of you. Oana, could you maybe explain a little bit what you are about to witness, about to see, and maybe also talk a little bit about the facilities you're going to visit, because I'm not sure if every one of our viewers is totally familiar with this marvelous instrumentation we have in the Southern Hemisphere.
So we are organizing a trip dedicated exclusively to people who are using social media, so to keen social media users such as Remco here. And we did a short competition to select only 8 people. Normally these social media gatherings are open to everybody, but because our telescopes are in such a remote places like the Atacama Desert, it was impossible for us to host an unlimited number of people. So when we decided to do this, we said, okay, we have to select only a limited amount of participants. So this is how we arrived to these 8 people that have been selected to join the trip. And we are going to arrive in Chile on the 7th of May, and through the course of a few next days, we will be traveling to 2 sites that ESO has in Chile. the Paranal Observatory, and the ALMA, the Atacama Large Millimeter Submillimeter Array site. At Paranal, we will mainly show the people the Very Large Telescope, which is the world's most advanced visible light observatory. It consists of 4 unit telescopes with mirrors of 8.2 meters and 4 auxiliary telescopes with mirrors of 1.8 meters. So they will see the Very Large Telescope. We will witness how the dome open at night. We will offer them a sunset experience from the platform. They will be able to visit the control room and see how the astronomers are operating the telescopes and how they are observing. And part of this program is also, of course, on the 9th of May when the transit happens, is to observe the transit. We will observe it, though, during the day with a normal telescope, a small telescope that we have at Paranal, which is has a nickname of UT5. It's like a completion to the other main UT, 4 main UT telescopes. And after the transit, we will go on and do some nighttime observations, also with this telescope, and we will visit some other facilities that we have in there. Then we will depart to the ALMA site. So if Paranal is situated at 2,600 meters, at ALMA we will be going up to even 5,000 meters. That's where the arrays are placed. It's going to be not a very long visit because you're not allowed to sit there for a long time without a more complex medical checkup. And also it's not indicated to spend a lot of time in an environment where the oxygen is a bit thinner than usual. So they will have a short medical checkup, also for the 2 or 3 hours that we are going to spend there. So I think everybody, myself included, is a bit nervous to make sure we're passing this test because we all want to go up there.
Very well. Speaking about the day, there's many hours of time shift between Europe and Chile, of course. Could you briefly address the starting and the end time of the Mercury transit if you have them at hand? Otherwise, I can briefly look it up here.
Sure. So the transit starts at 12 minutes past 11 UTC. I have the timings in Universal Time. Then the midpoint of the event will be at 3 minutes to 3 o'clock UTC. And then it will end at 42 minutes after 6 o'clock. So it's going to be, from early morning to the evening.
That's awesome, because that actually means that if you're in Europe, that is a perfect lunchtime astronomy event, because when you have your lunchtime, it will be visible, or during the Mercury transit will be available to see. However, if you're in Chile, it's going to be a breakfast astronomy event, a rare thing, obviously. Doing astronomy instead of or together with a breakfast, hot coffee on the catwalk of a telescope, maybe.
That's true. In Chile, it will start in the 8 in the morning, roughly 8 o'clock in the morning, and end at about 4 o'clock.
Just perfect. Although, of course, the subjective time zones of the astronomers working in ESO are totally off normal there locally anyway, because they live during the night and they sleep during the day like vampires. However, speaking about the rarity of events, David, you briefly mentioned our preparations that although Mercury transits are not a super rare event, but they're also nothing happening every day. David, could you elaborate about the numbers in terms of how often those events happen, like the Mercury transit?
Yeah, sure. I mean, Mercury takes only 88 days to go around the Sun, so it overtakes the Earth several times a year, but usually it passes either above or below the Sun, because Mercury's orbit is inclined to our orbit. So we can only see a transit of Mercury when Mercury is passing the Sun at the point where the Earth and Mercury's orbit are crossing each other. So that's either May or November. So the next transit of Mercury is actually happening in November. It's the 11th of November 2019. And that will be a good one to see for us in Europe, because like this present one, it starts at lunchtime and it finishes just before sunset for those of us in Europe. and that'll be very similar timing for the November 2019 transit. Then the next one is not till 2032, so we have quite a while to wait. So whatever we're doing to get ready for this one and getting people excited about watching it, they can all do it again in 3.5 years' time, and then have to wait.
Wow, that's quite a long wait, I have to say. Now,
not as long as a transit of Venus. It's not a transit of Venus for 100 years now.
Absolutely, absolutely. Remco, we have a question from somebody who seems to be interested in taking pictures and videos of the event itself. Again, a question from Daniel Jan saying that he has a small telescope with SLR camera. And how long will the transit be? Fast, short, or slow, long time period? Can I take video, or better to just do a bunch of photos over the long period of time? So what's your recommendation? I know that you have a very good hand at taking excellent pictures of the night sky, usually.
Well, thank you. Yeah, night sky. There's a big difference, of course, between the night sky and an event that takes place across the sun. But the transit, as you announced, it's a lunchtime event. It's actually much longer than that, of course. It takes, if I'm correct, about 8 or 9 hours.
7.5.
7.5. Thank you, David. For transiting the sun, so you have some time. If you have the right equipment, if you have the right solar scope with the right protection, you should be able to use a DSLR and make some sort of a time lapse, for example. So take a picture now and take pictures every 15-20 minutes and stick them all together, and you'll see a perfect time lapse that shows the entire transit. Video should also work if you have, well, if you can tape 7.5 hours and then extract that, but I think this is perfect for time-lapse photography. If you know how to do solar photography, this is a perfect event.
Gabriele, we are almost at the end of this Hangout for now, and I think I guess that you must be also pretty excited having a spacecraft en route, so to say, almost to meet the messenger or the god, so to say. When do you expect to have the first images close up? So how long do we have to wait for the next generation of science tsunamis in terms of images and data?
So we have to think that the launch will be just in 2 years, and then it will take more than 6 years to arrive to Mercury. It means that we should have the first images at the beginning of 2025. And this is important to note that it seems to be very close, Mercury, but in terms of cruise, the time that we need to arrive to Mercury, it takes a lot of time, more than arriving to Jupiter. And this is something that is important to know because Mercury is very close to the Sun. That is the space-time curvature. This is the reason why it's difficult. It takes a lot of time to arrive to Mercury and to insert a satellite in orbit around that.
All right, so it is indeed, we should not think about distances when talking about spacecraft travels, but more in terms of delta V changes and gravity wells or so. It's a different kind of thinking than if you're driving a car on the road, I would say. We have another last nice question from Olivia Heider from the about the I think that's best addressed to Oana, and she's asking hashtag Meet ESO is such a great event. Are you planning on additional events like that one? Is there any rumors you can share with us at this point now?
At this point, we're not considering another one. We're curious to see how this first one works and how people are enjoying it. But I probably can say that once we open the ESO Supernova Planetarium and Visitor Center that is currently under construction at our headquarters in Germany, we would be able to organize more such events also in Europe, and that would be much easier to set up.
Understood. Very well. Even if wherever you are and present or then observe the observe the transit. Even if it's bad weather, there are other ways how to see it. There will be plenty of broadcasts from various organizations, including the European Southern Observatory, including, of course, European Space Agency as well. They will broadcast from various satellites, actually, including the Solar Dynamics Observatory, like from SOHO. There will be Earth-based observatories broadcasting live this Mercury transit events. So there's a lot of things to see, even if you're not able to step out of your office. Again, it's perfect for your lunch break. It might be perfect if you are in Chile for your breakfast session, so to say. Having said that, I would say a big thank you to the 4 participants. Again, David Rothery from the Open University, Oana Sandu from ESO, Remco Timmermans from the International Space University, and Gabriele Cremonese from INAF. My name is Gernot Groemer. I'm with the Austrian Space Forum. In 1 week from now, we will again meet here with a slightly different composition of the podium. So we will again have David, and we have other very exciting partners to talk to. We will be talking again about the Bekaa Colombo mission. We'll be talking about actual observing hints, and maybe a little bit of amateur astronomy be included in this as well. Again, please be safe when you do this observation. The sun can be hurting your eyes if you don't use proper observation equipment. However, the one which is certainly the safest one is the internet, where we are right now. Having said that, I wish you all the best, and good night to wherever you are. Bye-bye.
Good night.
Good night.